Hi everybody. So far within our three-dimensional shapes portion of our geometry unit, we have talked about surface area and how to calculate the surface area that covers the outside of a three-dimensional figure. And what we're going to talk about today is the volume of three-dimensional figures, which represents how much space can go inside or can fill the three-dimensional shapes. Specifically, prisms is what we're going to look at. One thing about volume is it's measured in cubic units. Okay, area is the amount of space along a surface, which is measured in square units, the number of squares that fit along the outside of an object. Volume needs to be measured in cubic units because it's the amount of cubes that can fit inside of an object. So you can kind of see that here. We're filling each shape with a certain number of cubes, and that would represent the volume. So the formula for this, the formula for volume, I have listed right here. V equals capital B times H, which is not base times height. B stands for the area of the base times the height. And I actually have that listed here as well, if you want to circle, highlight, whatever you need to do. So to find the volume of the prism, you calculate the area of the base shape times the height. And remember, the base of our prism is the shape that it is. So this is a triangular prism. The base would be this triangular face. This is a cylinder, kind of like a circular prism. So the base would be the circle. Our rectangular prism actually doesn't matter which side we use as the base because all of the faces are rectangles. But let's say we chose this side as the base, this square side as the base. We'd find the area of that times the height. And the height is kind of the distance that that base shape was extended. So if we found the area of this base, we'd multiply it by this height. If we found the area of this base, we'd multiply it by this height, the shorter height. So it's not as particular for rectangular prisms because you can use any side as the base, but for shapes such as triangular prisms, the base does need to be the shape that it is and multiply it by the height that that shape was extended. And I want to explain why this formula works, why it is what it is. And it's in this box over here. It says the area of the base gives the first layer of cubic units, and that is multiplied by the height to create the multiple layers on top. So if you look at this shape, this looks like it's a cube. If I find the area of the base, if I'm looking at the area of the bottom face, looks like it's about 4 by, about a 4 by 5. So the area of that bottom face is 20. And that's also the number of cubes that would fit along that bottom layer. And if I multiply it by the height, then that's just times 4, which also is just how many stacks of those layers of cubes I need on top of each other. Once again, you can see that over here. If I'm looking at the bottom face, if I'm saying that's the base, I find the area, which is 5 times 3. So 15 cubes would be along the bottom of that shape. And I multiply it by the height, multiply it by 4 for those 4 layers of cubes stacked on top of each other. And that would work for a triangular prism too. If I found the area of this base, that would be the number of cubes along that bottom layer, and then multiply it by the height for how many layers or stacks of cubes I would need on top of each other. So that's why the formula is what it is. Hopefully that helps explain it a little bit better. So let's calculate the volume of certain shapes. Our first example is a rectangular prism. Once again, it really doesn't matter which face I use as the base. I will typically, actually really it doesn't matter. So I would maybe do this bottom face as the base, so 9 centimeters times 5.4 centimeters. That's the area of the base. And I multiply that times the height, which would be 4. So 9 times 5.4 times 4 is 194.4 centimeters cubed. So that's the number of cubic centimeters, the number of little cubes that could fit inside of that object. Once again, you didn't need to use this bottom one as the base. You could have used this front face as the base, and then the height would have been that 5.4. So you could have done 4 times 9 and then times 5.4. So really the shortcut for rectangular prisms is just multiplying all of the numbers together. Length times width times height. But the reason that we can do that goes back to our formula that works for all prisms. So if you want to, here you can just do 2 times 3 times 6, or really in any order. But the reason being would be, 2 times 3, if we're using this side as the base, then 2 times 3, which is 6, would give us the area of the base. And then 6 feet would be the height that that base was extended. So that's why we would multiply that by 6. And 2 times 3 times 6 would give us a volume of 36 cubic feet. And once again, I might sound like a broken record, but I really just want to drive home why this works. Okay, the area of the base is 6 cubic feet, or 6 feet. So 6 little cubes would fit along this first layer, and then you'd stack 6 additional layers on top of that to get the 36. All right, next one is a triangular prism, and once again, we want to find the area of the base and multiply it by the height that it was extended. So the area of the base would be the area of this triangle, which hopefully remember is 1/2 times the base of the triangle, which is 19, times the height, which is 24. So that's the area of the base, which is a triangle. And then we multiply that times the height, which is 47. So I'm just going to multiply these all together. 0.5 times 19 times 24 times 47. And you get a pretty large number, 10,716 cubic centimeters. All right, we have another triangular prism here. It's just kind of propped up on its triangular base like this. Normally we're used to seeing them like that. But here the triangle is still the base, and hopefully you can kind of see that the height and the base of that triangle are given. So to find the volume, we want to start by finding the area of this triangle, which would be 1/2 times the base of the triangle, which is 12, times the height of the triangle, which is 16. So that gives us the area of the base, and we multiply it by the height that it was extended, which according to our image is 20 meters. So 1/2 times 12 times 16 times 20, so 1920 cubic meters. All right, this next one is another triangular prism. So once again, we find the area of the base, and the base of this shape is the triangle, times the height that it was extended. So the base and height of this, or to find the area of this triangle, I do 1/2 times the base, which is 1.5, times the height, which is 2. So that's the area of the base triangle. And I multiply that by the height that it was extended, which is times 10. So, I think this is going to be 15, but let me double check. Yeah, 15 cubic meters. All right, this next shape is kind of weird. It is a prism, and if you look at the base shape, it's actually a trapezoid. This is called a trapezoidal prism, and it's kind of uncommon, but nonetheless, we can find the volume of it. We take the area of the base, take the area of this trapezoid, which hopefully we remember that formula. It's 1/2 times the height, which is 6, times the 2 bases added together. So this one's 8, and this top one, it's listed over here, but it's 5. So that's the area of the base shape, which is a trapezoid, and then times the height. So you can do this all in one step on your calculator. Just put the addition in parentheses. So 1/2 times 6 times parenthesis 8 plus 5, or you can just do that addition in your head, which is 13, times 12, and you get 468 cubic units. And then our last two shapes are cylinders. And the base shape of the cylinder is the circle. So I find the area of the circle and multiply it by the height of the cylinder, the height that it was extended. So remember, the area of a circle is pi times the radius squared. The radius in this circle is 6 inches. So this would give me the area of the base circle. And I multiply that by the height, which is 18. So get your calculator. Pi times 6 squared, or 36, times 18, and you get approximately 2036, if I round up, cubic inches. And then our last cylinder, we're going to take the same approach, but we're given the diameter and we need the radius for our formula. So the area of this circle would be pi times the radius squared, so pi times 2 squared. The diameter is 4, that means the radius would be 2. So that gives us the area of the base shape, which is the circle, and multiply it by the height it was extended, which is 5.8. So pi times 4 times 5.8. You get about 73 centimeters cubed. All right, so hopefully that helped you understand how to calculate the volume of 3D shapes. I am going to have you watch a video to further get a visual of why the formula is what it is, and then you'll be able to practice some on your own. So, good luck.